This is Big Data Analytics E63 final project, follow-on video with the Spark analysis for NLTK. The Tweepy and Twitter feed side of everything and Kafka producer is the same as before, so I'm just going to focus on the Spark analysis. We see here setting up the Spark context, streaming context. This is very similar to before, where we're doing NLTK regex parsing on a grammar pattern. The difference here is that we're returning the tokenized sentence that's passed in, and I'll talk more about that in a moment. But it's basic sentence and word tokenizing here. And frequency distribution, basically the same as before, and again just returning back to the Spark stream after printing out to the console. So down here, sets up the stream, direct stream with Kafka, and then it's just a few series of Spark functions here. So first, it tokenizes the sentence or the stream into the sentences, and here it is basically using lambdas to get down to the individual sentence in the list. So there's basically a list of sentences, and then that gets repeated. And so here it takes the individual sentence and it word tokenizes it, and then passes that to the chunk detector. And so we'll jump back up to that code. And so it takes that, and this is very straightforward as before, just does the regex searching on that. If there's a match, it prints out the little tree, and which is basically just text, not the graphical tree. But the key thing here is then it returns that input tokenized sentence back to Spark. So all Spark is doing here is basically jumping into this function, doing this NLTK processing, and then jumping back out and continuing on its stream. So I'm not accumulating that data in Spark right now anyway. So that gets passed back, and then so it builds a list of word tokens. Now those word tokens, we don't want to run frequency distributions on each individual one, because that's a very small amount. So whereas in the Kafka version, it was basically just accumulating a list over a certain amount of time. So here in Spark, we're using a window function. So for every 20 seconds, it accumulates data, or for a 20-second window, every 10 seconds. And it reduces by window. So it basically puts this into a list of words, and this was the only way to get a list of comma-separated words for the frequency distribution function in NLTK. It took a while to get the data in the right format. This turned out to be very simple, just took a while to find it. And so then this word aggregate is the list of words over that window period, and then that is fed into the frequency distribution function just by doing a map and then the function name. And then we jump up here, and this is very similar to before. Just does checks for alphanumeric, and then removes the stop words, computes the frequency, prints it out to the console, and then it returns that list back to Spark. And then it just does a repartition and prints it out to the text files. So this, the plotting thing didn't work because, as in Kafka, because the Spark process is different, and each time it runs through this, in the Spark sequence, at the end of each window, it wants to generate a new plot, even though up here in the plot function, I'm passing the fig and the AX back in and trying to set the current figure to that figure handle that was passed back in, but Spark still wanted to, or the process still wanted to open a new plot window, so you don't want to have too many of those opening up. So that scheme is not going to work here in Spark. So that's it. It writes out to the file, and so we'll crank up a little demo here. Here's the consumer going, and I have just a different number here because I removed a couple things there just for demonstration purposes. And we'll fire up the Twitter feed. So tweets are coming in, and there we see Spark processing. And getting some hits on the grammar patterns. And it's computing top 10 for the windows here we see. And we have output here in the Spark output directory. Then okay, so we go there, and so now we see the familiar Spark output. And 147 bytes, so open that up. And this is just the frequency distribution for that window being output. And so probably have to write a separate Python script that can just pull the directories and just read the latest distribution and plot that out. And there you have it, near real time NLTK Spark text processing with Kafka and Twitter.